Today we will learn about area of composite figures. So, areas of composite figures. To find the area of composite figures, you want to decompose, which means break down, the shape into smaller shapes that you already know the area of. So a couple of formulas we have here is, the first one is triangle. The area is 1/2 times base times height. Trapezoid. Area equals 1/2 height times base 1 plus base 2. And here you want to be sure to add base 1 and base 2 before you multiply it by the 1/2 in height. Parallelogram, which may be a rectangle or a square. You have the base times the height. And last but not least, the circle, which area equals pi times the radius squared. So just a simple look of some composite figures that you may come across. We have this figure here, which is composed of a rectangle and a parallelogram. Parallelogram most likely are going to have the slanted lines within it. So it's just like a rectangle, but it may be tilted just a little bit. Here you have a semicircle with a square. Now notice you did not see the area for a semicircle. You're simply going to use the area for the circle and then just take half of that or divide it by 2. I know this is a square because I see the ticks. And if there is one tick on each side, that means these sides are congruent, which means all sides are congruent, which makes it into a square and not a rectangle. Here I have, and you do not see a square or a rectangle. It's the same thing as a parallelogram. So you will still use area equals base times height for that one. Here I have a triangle and a trapezoid. And those areas are provided. So now we have example 1. The first thing you want to do here when you come across a composite figure example is to understand or realize what 2 shapes that you're dealing with, or however many shapes there might be. So I know here I have a rectangle because I have 2 different side lengths. And then I have a triangle. Then I want to draw the rectangle, and I want to draw the triangle. Now I'm doing this so I can get all of my components that I need, okay? So rectangle, the height is 15 inches, and then the base is 23 inches. For the triangle, I need the base and the height. So the base, the height is 8 inches, it gives it to us. And for the base, I know that this entire part right here is the base. So what's missing is this piece right here, the dotted line part. Now, however, I know that that is 15 inches because this is a rectangle and parallel lines in a rectangle are congruent. So I know that this is also 15 inches. So in order to get the entire base of the triangle, I need to add the 6 inches plus 15 inches plus that 6 inches there. So in order to get the base, I will add 6 plus 6, that is 12, plus 15, and that will give me 27 inches. Now, the next step is simple. Write the formula, okay? I want to write my formula. Rectangle or parallelogram is area equals base times height. The triangle is area equals 1/2 base times height. Now I need to fill in, which is why we did this step here. So I do not have to go back up to the figure anymore. It's just simpler to look at the figure once we separated it. So the area equals 15 times 23, which gives us 345. This area equals 1/2. The base is 27. The height is 8. So it doesn't matter which order you do it in. 27 times 1/2 is 13.3 times 8. It's going to give me 108. So I still have to add because we're not finished. So 108 plus 345 is going to give me 453 inches squared. So the final area is 453 inches squared, or square inches. Alright, so number 2. First step, again, is to identify what smaller shapes we see. So I see a semicircle. Plus a triangle. My next step would be to draw the shapes that I have split up. So I have a semicircle here, looks like this. Then I have a triangle. We can draw it upright. You can draw it as it is or upright. I prefer to draw it upright, okay? So now, we need to add our dimensions. So the semicircle has a diameter of 6 millimeters. And that would also be the base of the triangle. In composite figures, they are going to share some sides. So yes, 6 millimeters can be the diameter of the semicircle and the base of the triangle. And then they give us a height of 16. So here we did not have to do any extra work in order to find out the base or the height of the triangle like we did in example 1. So next step, we've written down what we've seen. We broke it down in the picture form. Now the next step is to write the formula. So we have a semicircle. So that area equals pi r squared. And then we know we have to divide it by 2. Triangle. Area equals 1/2 base times height. So when it's time to fill in, we have the area of a circle 3.14 times 6 squared. Then we're going to divide it by 2. Remember to do exponents first, so 6 times 6 is 36. So we'll move this off to the side. 3.14 times 36 will give us 113.04, and want to divide that by 2, and we get 56.52. All right, now I want to do the area of the triangle, which is 1/2. The base is 6, and the height is 16. So 1/2 times 6 is 3, times 16 will give us 48. So our area will come out to be 56.52 plus 48, which is 104.52 square inches, or you can say inches squared. All right, example number trace, which is 3, by the way. So in this example, if you notice, we have 3 smaller parts this time instead of 2. However, we are going to do the exact same thing. Alright, so what do we see? Well, we know we see a rectangle. And then we see 2 trapezoids. Now, one, we know that these trapezoids are going to be congruent. Congruent means they are the same size. 2 ways we can tell that. One is because, well, the main way, because there are no measurements down here. Alright? So, we already know that they're going to be the same as the one at the top. Also, they have the same base because they share a common side, which would be 18 from the rectangle. Alright? So, we have 2 trapezoids. So, we're just going to do 2 times trapezoid. Okay? Now, we want to draw them out. We've identified what we see. Now we want to draw them. We have a rectangle plus a trapezoid. And you only have to draw, well, we'll go ahead and do 2. So we make sure we do not forget. Okay? So we got 1 rectangle and 2 trapezoids. So let's fill in. We have the height of the rectangle is 18 feet. And the base is 20. You can flip, it really doesn't matter, okay, as long as you get the correct measurements for the trapezoid. Now, in our trapezoid, our base is 18. One of the bases are 18. The height is 5 feet. And then the top base is 10 feet. So here they gave us everything we needed in order to figure out the area of these smaller figures. Next step, we should know by now, is to write the equation. So step 1, write what you see. Step 2, draw what you see. And step 3, we're going to write the formula. So for a rectangle, which is the same formula for a parallelogram, the area equals base times height. For the trapezoid, area equals 1/2 times height plus base 1 times base 1 plus base 2. Alright, so for the rectangle, the base is going to equal 18, the height is 20. We multiply those 2 together, we get 360. It's going to be 360 feet squared. Now, the trapezoid, okay? We have 1/2 times the height. The height is 5 feet. Then base 1 is 10 plus base 2, which is 18. Okay? Now, you want to be sure to go ahead and add base 1 and base 2. So that will bring us to 1/2 times 5 times 28. Now we can just multiply straight across. So we have 1/2 or 0.5 if you put it in the calculator that way, times 5 times 28, which will give you 70. Okay? So if this trapezoid is 70, then we know that this one is also 70. Okay? This one is also 70. So now we have 360 plus 70 plus 70. That will give us 500 feet squared. 500 feet squared for this composite figure. Or 500 square feet. Now you can try the last example. You can pause it now and try the last example. Alright, now trusting that you've paused and worked this example out, we're going to go ahead and go over it. So, what do we see? Alright, I see two rectangles. So I'm going to write a rectangle plus a rectangle. See, rectangle plus a rectangle. So you can split this rectangle up in two ways. Some of you probably split it up this way, horizontally, or you split it vertically. Either or, okay? It really does not matter. I'm not going to put any thought into it, and I'm just going to erase this line. So I'm going to split it this way, okay? So I can draw two rectangles. I've written what I can see. Now I drew what I saw. Now I'm going to fill in the dimensions. So first rectangle, I have 7.5 as my height. And then I need to figure out what this is here. Now, in order to figure it out, it's pretty simple, okay? If this is 9 meters here, then I know this part down here is 9 meters. If this is 6 meters here, then I know that if this is 6 meters here, then I know this part here is also 6 meters. So in order to get this full length, I have to add 9 meters plus 6 meters, and that will give me 15 meters. Okay? 15 meters. Now, probably drew too much. Now for this rectangle here, I know that my base is 6 meters. Now I need to find a side. I need to find this side here. Okay? So this entire side is 15, and I know that because it states it here. I do not need this part. And because this part is 7.5, then I know this other side is 7.5. So in order to find out what this is, I have to subtract 15 minus 7.5, which will give me 7.5. Okay? Meters, 1 our units. So this is why we break down, because if we try to actually write the equation and just plug in just by looking, it might be a bit confusing. So this is the reason why we break down into two separate figures and we can see the dimensions. So next step, write the formula. Both of them are areas, so I should be writing the same formula. The base is 15 times 7.5 is the height. That gives me 112.5 meters squared plus, fill in, the base is 6, the height is 7.5. 6 times 7.5, give me 45, cool. Add that to 112.5, and I get 157.5 meters squared as the area of the entire composite figures. So, quick review. The first step is to understand what you see and then write it. Rectangle plus a rectangle. Second step is to draw what you see and then fill in the dimensions. Write the formula Okay? Plug in into the formula and then add your answers for both of the areas, and that will give you the area of your composite figures.